Welcome to Chapter 4, Section 9, Graph and Solve Quadratic Inequalities. Start off by writing the fact that quadratic inequalities in two variables and quadratic inequalities in one variable is exactly what it sounds like. It's a quad with an inequality that has two variables. Whereas down here, it's a quad with an inequality that has only one variable. Those are the differences. So the first thing you need to do is make a parabola dashed for inequalities with less than or greater than, and solid for inequalities with the equal to part. Then you test a point not on the parabola to determine whether the point is a solution. Shade the region blank the parabola if the point in step 2 is a solution. And I'm going to actually have to make step 3 make sense, I'm going to have to change this to say that you should test a point in the parabola to determine, and then shade the region in the parabola if the point in step 2 works. Shade the region outside of the parabola if it's not a solution. Basically what you're looking at is you're looking at a graph. Here's a parabola. Pick a point inside, preferably 0, 0. If 0, 0 works, you shade inside. If you have a parabola and you choose 0, 0, if 0, 0 does not work, you shade outside the parabola. That's what this is talking about. So let's check out this first one. You're going to have to remember that the vertex is at negative b over 2a, which for this example is negative 2 all over 2 times negative 1, which is negative 2 over negative 2, which is 1. 1 is the x value for the parabola. You find the y value by plugging it in. So negative 1 squared plus 2 times 1 plus 3. That's negative 1 plus 2 plus 3. That's negative 4. So 1, oh, not negative 4, I'm sorry, positive 4. 1, 4 is a solution. 1, 4 is a solution. Then, of course, 0c is the y-intercept, so 0, 3 is the y-intercept. You pick a point inside the parabola, so you can go ahead and pick 0, 0 if you want, and plug it in. 0 should be less than 0 plus 0 plus 3. Is 0 less than 3? Yes. So you shade every single piece inside of the parabola. All right, so let's try this one. Well, let's graph it. So this time, negative b over 2a is 0 over 2 times 1, which is 0. When you plug 0 in, you get negative 2. So my vertex is at 0, negative 2. Now, since the vertex and the y-intercept are the same, you have to choose a new x value. So we'll choose 1. 1 squared minus 2, that's 1 minus 2, or negative 1. So 1, negative 1, the mirror image, it's dashed And now we have to determine where to shade. So we pick a point inside the parabola, like 0, 0. You say that 0 is greater than 0 minus 2, so 0 is greater than negative 2. That is correct. So since 0, 0 works, that inside part is the region we shade. All right, let's take a look at guided practice number 2. It says y is less than or equal to 2x squared minus 3x plus 1. Well, negative b over 2a tells us that we use negative 3 all over 4, which is 0.75. When you plug 3/4 into the equation, you end up having to probably do a little bit of work or maybe even use your calculator. So like I said, after plugging it in and working it out, you should get negative 1/8, I believe. So that's the vertex. 3/4, negative 1/8. Y-intercept of 1. Somewhere over here. There's your parabola, opening the correct direction. Now what we're going to do, though, is we're going to go ahead and look at not a point in the parabola, but outside, because we're going to check 0, 0. Is 0 less than or equal to 1? Yes. So you should end up shading everything outside. All right, for this one, we're actually going to have to graph both. So to begin with, y is greater than x squared minus 2. Well, that's negative b over 2a, which is 0, negative 2. So 0, negative 2 is the vertex. Oops, sorry, wrong direction. Lots of mistakes tonight. 0, negative 2 is a solution, or the vertex. Now we're going to pick another value like 1. 1 squared minus 2 is 1 minus 2, or negative 1. So 1, negative 1 is right here, point right here, and of course we're using a dashed line. Now 0, 0 we should check to see if it works. Is 0 greater than negative 2? Yes. So we shade every single thing inside the parabola. Now the next one, negative b, would be 3 over 2 times negative 1, or negative 3/2. Now that's what you plug in to find the other part of this graph. So go ahead and plug that into the equation and see what happens. So you should have then that it's approximately negative 1.5, comma 6.25. So negative 1.5, 6.25 is 2, 4, 6.25 is about right here. Plug in a 0 and you get 2, 4. It's an equal to, so it looks like this. Now I can guarantee you, for this example, my graph's not very good, but 0, 0 is not on the line. So test it. Is 0 less than or equal to 4? And you should say yes. So you shade the inside area. That includes the 0, 0. Now it just so happens, though, the only answer here is actually the double shaded region. So that's your solution. So let's go ahead and work this one out. Negative x squared plus 3 gives us a y-intercept of 3. Oops. 3. And it opens down and it's dashed, so it looks like this. And when you test 0, 0, you find out that 0 is less than 3. So it's every single part inside of the parabola. The next one, though, is a little bit more work. Negative, that's 3 over 4, negative 3, opposite of b over 2a. And when you plug it in, all right, looks like you missed a little bit of this, but if you plug everything in there, you can see that it should be this double shaded region. And you've seen a couple examples now. You should be able to finish the guided practices and finish this on your own as well. So moving over to the table. You should know how to plug in each of these numbers in to fill out this table. You then will notice that when this equation is less than or equal to 0, when the values of x are between the two numbers. So go ahead and fill this table, pause the video and fill this table out. Alright, so your table should come out in this way. And now notice that in which part of the table is the equation less than 0. Well, if you're looking carefully, you'll see that from right here all the way to right here, the equation is less than 0. So when the values x are between negative 3 and, oh, I'm sorry, not negative 3. So the solution to the inequality is that x should be greater than negative 4, but less than 1, not inclusive. Or no, inclusive because it's equal to. So let's use a table for this one. Go ahead and fill out an XY table. What you're really looking for is when this is 0, when the y values are 0. So go ahead and pause the video and try to find that out. Alright, so you should have come up with somewhat of a table like this. You should have seen that right here is when it's equal to 0. And when it's equal to 0, we want to know though when it's less than or equal to 0. So the only part that is less than is everything in between negative 3 and 1. So you go ahead and say negative 3 here, 1 there. X is in between. And that's your solution. You can do it by graphing as well, because you're looking for the solution consists of the x values for which the graph lies on the x-axis. Find the graph's x-intercepts by letting y equal 0 and using whatever way you want to solve. You could say completing the square / quad / factoring, whichever way you want. So what we're going to do here is we're going to go ahead and graph this. Go ahead and graph it on your own. Pause the video, graph it on your own. Alright, so I'm just a couple seconds into this using the quadratic formula to solve this. This number here is 25. Minus a minus is a plus. And you're plussing 36, which gives you 61. So that means your solutions are at 5 plus or minus the square root of 61 over negative 6. And so that gives us a strange kind of solution. It tells us some approximations actually. Alright, so that's where your solutions begin. So 4.47 is about right here. All right, there. Now we have to determine inside the points or outside of the points. So sketch a parabola that opens down and has 0.47 and negative 2.14 as x-intercepts. Graph the line, graph the graph lies blank, the x-axis to the left, and include those. So I'm going to pick 0, 0 again. Put a 0 in there, so 0 minus 0 plus 3 is 0 less than or equal to, is 3 less than or equal to 0? You would say no. So that means this is a big fat no, and it should then be everything to the outside. So x should be less than 0.47, or x is greater than, got to reverse that. X is less than negative 2.14, or x is greater than 0.47. Alright, I think you pretty much got the understanding here. Why don't you fill out the rest of these on your own and go ahead and do the check the rest of your guided practices, and we'll do these in class when you return. Good luck.